There was a time when a lot of very smart people believed the benefits of computing would be forever exclusive to the most prestigious academic institutions and the world's largest companies. But that was before computing got personal. Fast forward 50 years, and there's a new kind of personal revolution underway. A revolution that promises to make the expanding benefits of artificial intelligence available to virtually every person on Earth, in smart cities, transportation, healthcare, manufacturing, pretty much everywhere people live, work, and play. AI will increasingly leverage the invisible power of data to improve human lives and enable breakthrough business outcomes. And it's all thanks to the continued development and mobilization of a global ecosystem designed to accelerate the growth of the technologies, tools, and companies that will drive the breakthrough, democratizing, and personal impact of AI. So just like the cloud gave computing access to companies of every size, and the mobile revolution put applications in everyone's pocket, AI is starting its own revolution. And it's about to get personal. All right, thank you for coming. We're going to spend a very engaging hour. Thank you so much. My name is Jonathan Ballon, and I work with Intel's customers that are deploying technology at the edge, outside of the data center. And what they're doing is can best be described as Internet of Things, right? It's this broad term that really represents this idea that anything that can compute and can connect to the network will. And there's been a tremendous change that's happened over about the last 5 years, where we went from a place where devices were smart, meaning they could perform a single function, to devices that are intelligent, meaning they can not only perform multiple functions, but they actually have the ability to learn. And what we're going to talk about today is how enterprises, whether it be healthcare companies, manufacturing companies, cities, are embracing this technology and leveraging the power of AI, and specifically deep learning, to dramatically change outcomes for their customers, for their citizens, et cetera. And really this growth and this adoption of deep learning and AI is accelerating our Internet of Things business. And if you think about what the video was trying to talk about, was this idea that the cloud really democratized computing. So what was historically limited to companies and academic institutions with vast resources, now you were able to deliver computing resources to essentially a developer in a dorm room. And similarly, what we're experiencing now is a hollowing out of the network and an emergence of this distributed computing architecture that we've been talking about for decades. So what we've experienced in the cloud for the last 15 years with this massive economies of scale around computing and network and storage, we're now seeing what is almost a cloudification at the edge. So all of the things that manifested themselves and drove the democratization and access to those resources in the cloud is now happening at the edge and furthest reaches of the network. And so we now have these distributed computing architectures where workloads, AI capabilities, can be optimized at any point in that architecture or in that network based on whatever use case or constraints you're trying to optimize for. And so what's accelerating this trend is the availability of neural networks that are capable of performing cost-effective inference at the source of the data origination. And one thing we've learned over the last 5 to 7 years is that the majority of the data is actually going to stay at that point of origination. It's not going to move to the cloud. In fact, close to half of it will be processed, analyzed, and stored locally on-prem in factories, in hospitals, in retail stores, and in our cities. And the opportunity that exists, therefore, in the physical world to to access that data and to learn from and act upon that data is far greater than what we've already processed in the cloud. So what we'll do for the next hour is talk about why this is happening, exploring the journey that other companies have taken, and I'll invite a couple of guests on stage to join me. We'll show some demos of how we're democratizing and making the technology available to anyone, and really, hopefully learn from each other. Does that sound good? All right. So, of course, AI has been around for decades, but there was a pivotal moment that occurred in about 2014, 2015, when essentially neural networks demonstrated that inference could be as good or better than humans. And that was in the form of ImageNet, when Google and others demonstrated better than human accuracy for natural language processing and for object detection, object recognition. But at that time, it was really limited to those with vast computing resources. So these were, massive computing clusters in a cloud that were tasked to solve these problems. And the ability to do so was really limited, not just to those that had access to computing resources and training data sets, but also those that had highly skilled programming capabilities or proprietary APIs. So if you think about the technology adoption lifecycle, this was really the early adopters. And there was really one architecture that was being used. It was a CPU and a GPU combined, and that hammer was being applied to every AI task. What we've seen since and where we are now is really AI being deployed in a variety of use cases outside of a data center at the edge. And what we've seen is a kind of a democratization of the tool set. So no longer do you need deep programming skills to be able to develop and train a neural network. So whether it's TensorFlow, PyTorch, Onyx, MXNet, et cetera, all of these tools are now available so that application developers and data scientists can very quickly build interesting algorithms. And from a computing point of view, we're moving into kind of the early majority. And what people have learned is that there is no one-size-fits-all model. There are actually a variety of heterogeneous architectural options that can be explored based on whatever problem you're trying to solve or what constraint you're trying to optimize. So it's not just about a GPU or a CPU, but there's accelerator technologies that can be used to offload inference tasks, whether they be neural network processors, a vision processing unit, or an integrated GPU. So why is AI so important outside of the data center? It's because there is so much data that's being created in the physical world. I'm sure you've seen these stats. A smart factory will generate a petabyte of data in a day. That is 1 million times, or I should say almost 1 million times more than what an average internet user will create. So it's about over 650,000 average internet users a day will create the equivalent of what a single factory will produce. Just to give you an idea, in China alone, there are 500,000 factories. So just the explosion, this tidal wave of data, is more than we can possibly analyze through humans. And it holds an unprecedented amount of economic and social value, and we're going to explore some of that stuff today. Our ability to process the data means that we can tap into this rich data set. And according to this recent McKinsey study, there's about $13 trillion worth of economic opportunity over the next decade, which equates to over a point of global GDP. And it's not just at a macro scale that these economic benefits are real. Every industry is experiencing such a profound opportunity that it's causing an acceleration of technology deployment. companies are skipping the prototyping phase and going into production as quickly as possible to capture those economic benefits, to change the customer experience, to drive productivity, access adjacent markets. The opportunities are virtually limitless. But with that opportunity, or perhaps in spite of that opportunity, we have a challenge in terms of a limited supply of AI specialists. So this is putting more of a burden on our ability to build tools that can help automate and simplify the development and deployment of AI across all of these industries. Obviously, you can see this is kind of like the data scientists of 10 years ago that were commanding similar types of salaries right out of university. We're seeing the same thing now for AI skill sets. So it really is impacting every industry. So it started really, I think, in smart cities. Cameras are not new to cities. They've been around for a while. But what's been happening is cameras have gone IP. And once cameras became IP and became networked, and the ability to deploy traditional computer vision algorithms opened up a wealth of productivity for cities to optimize traffic, as well as to make city environments safer. But now, over the last 5 years, the deployment of computer vision algorithms and deep learning capabilities are really opening up all kinds of predictive abilities that can impact city lives. In the case of retail, as you hopefully saw this morning, the Amazon Go case is pretty remarkable. This idea to create a frictionless retail experience where you can take all of the customization and automation and understanding demographically of an online experience and be able to replicate it in a physical store is pretty profound. And I think Amazon did a great job this morning of communicating those benefits. But you know, it's not limited to Amazon. Around the world, this idea of even a staffless store is taking hold, where you'll be able to go into a store a fraction of the size of this room that will have inventory that is been predicted for the local demographic. Cameras are being put in stores to better understand not only the footfall, but the demographics of the people that are entering that environment to be able to influence merchandising decisions. Cameras are now being able to detect if inventory levels are running low on shelves or if products are mis-shelved. All of this is leading to higher productivity, a better consumer experience, and that information isn't just limited to the in-store experience, but it can translate to your online experience, as well as get pulled through the entire supply chain to increase the overall supply chain efficiency of how goods are brought to market. Healthcare is an industry that's no stranger to computer vision. Image analytics has been a huge part of that industry for the last several decades, and now we have the ability, using computer vision algorithms, to have as good or better accuracy and speed than a radiologist. And what that allows hospitals and healthcare providers to do is to really increase the value of their radiologist's time by focusing on the outliers and the corner cases. In the case of transportation, companies are using this to predict when train tracks need preventative maintenance. It's going in cabin for logistics and being able to understand if truck drivers are nodding off at the wheel or if they're drinking behind the wheel, which is remarkably a big problem in many parts of the world. And industrial is perhaps one of the biggest opportunities. Right now, cameras are going on to manufacturing lines to understand defects and dramatically reduce the defects of products coming off the line, which in many cases can reduce rework, but also increases, obviously, the utilization and output of quality from factories. We'll talk a lot about some examples over the course of our time today. A huge example of this is in worker safety. You heard a little bit about this morning in terms of how Amazon is using vests in their shipping facilities. It's actually a huge problem around the world, an $800 billion a year problem in the form of reduced productivity, liability and healthcare costs, as well as product issues. This is hugely important in construction, which is a very dangerous environment. It's important in manufacturing and in lab environments like pharmaceuticals. Millions of workdays a year are lost due to accidents. And this is something that's pretty easily solved with technology. An example of this is an effort between Cortexica and Cisco, where they put together a computer vision system that basically is a combination of cameras and edge servers that can detect whether workers are wearing protective gear. And if they're not, it prohibits them from entering the work site. What's interesting about this is that it supports real-world conditions. So it can work indoors or outdoors where there might be rain, bright sunlight, or poor light at the end of the day. And what it's monitoring are not faces. It's actually just monitoring the clothing. So there's no privacy concerns here. And let me show you an example of how this works. As you can see, this gentleman is wearing his protective helmet and his yellow vest, and he's able to enter the facility. This can handle hundreds of people simultaneously trying to enter a work site. And what they used is a tool from Intel called openveno, which I'll go into some more detail later, which is an inference tool that helps to accelerate the algorithms so that you're getting maximum performance where these systems are be able to basically respond in close to real time with very little latency, so people aren't having to wait to enter into the site. Because it's a flexible system, the algorithms can be updated as the circumstances change. So if different protective gear needs to be worn, those algorithms can be easily adjusted. There's also additional capabilities, like it can detect if a person's fallen on the job site. It can detect if a worker is working by themselves, which could be dangerous in certain environments. And also real-time alerts, so that if there's a dangerous or hazardous situation, it can actually shut down the power in a particular environment to avoid any high-risk situation. We're using computer vision on our own manufacturing facilities. As you can imagine, as a silicon manufacturer, we have incredibly sophisticated lab environments, and we've historically used manual human inspections to sort the quality of our product, which is a hugely important characteristic for us. And we tend to over-index. So we have a lot of false positives, and the result is that we were scrapping too much, and our filter was perhaps too fine to ensure that we were delivering the highest levels of quality. So what we did was we deployed a computer vision system running on Xeon servers using GoogleNet for inference, and the result was we very quickly matched the same level of accuracy as our human experts, meaning that no anomalies were slipping through. And now the humans, similar to the radiology case, are now focused on the outliers. And so their expertise is raised, and a huge improvement in productivity. Now let's get to one of our first in-depth topics, which is around smart cities. This is a great area to highlight the democratization of AI. And cities around the world have been rapidly adopting new technology to keep their citizens safe, to improve traffic, to automate parking, and a variety of other city services. And so what I thought we would do is talk a little bit about how smart cameras are being connected to edge servers running deep learning algorithms to detect and respond to what's going on in a city, because it's a hugely important problem, but it's also a tremendous opportunity. Congestion in cities costs about $300 billion a year and contributes significantly to CO2 emissions. In fact, many estimates that 40% of traffic in cities, for example, is a result of people not being able to find a parking spot. So the ability to automate that process, the ability to decongest cities by rerouting traffic using AI algorithms is massive. And increasing safety and security in parks, in stadiums, in schools, in train stations, by flagging suspicious behavior and being able to interpret human behavior can have a dramatic impact. So what I thought we would do is invite Ken Mills from Dell, who is the VP and GM of their AI and computer vision business, to maybe talk to us about what you're seeing, Ken, and your customer base, and learn a little bit from you and your customers.
Yeah, great. I have to say, one of my favorite things is the Google effort on cat videos, because I'm a big fan of all the cat videos I get sent on email, even though I'm a dog person, but who doesn't love a good cat video doing something they shouldn't be doing? So I really appreciate that engineering feat that was accomplished not too many years ago. So at Dell, we're very excited, much like Intel and those of us in this room, about what can computer vision do to really help make our cities safe, what it can do to make our schools safe, transportation centers safe, stadiums safe, all of the things, all the above. And we're really excited that cameras have become much more than just a sensor at the edge of a customer's network. They've become optical sensors that drive a ton of IoT data and a ton of valuable data that our customers can make real-time decisions with. And they've become so important to how companies and industries and cities operate that we do not see a customer that we talk to that isn't deploying surveillance cameras for business reasons, safety reasons, analytics reasons, or all the above. So it's an opportunity for us to really help those customers do it correctly and apply the right technology stack to solve the right problem. As an example, you talked about some interesting stats. There's 150 million cameras that were shipped last year alone. At Dell, we did over 2,000 petabytes of video storage last year alone across 35,000 servers, which is quite a few Intel processing chips.
We appreciate it, thank you.
Which we're very happy to do. And customers are saying, this is still not enough. We need more and more and more. And the data compound growth rate for video data is over 42% annually. So it's growing much faster than a lot of other data sets in our traditional IT world. And that's because it's bringing a ton more value than it ever has before. So we have some safe cities examples. We'll talk about one here specifically around Las Vegas. But we have a safe city where I live that had about 40 terabytes of storage 4 years ago. Today, we just shipped them 8 petabytes of video storage. And not just for video surveillance cameras, for body cams, in-car video, drones, helicopters, crime scene investigation, digital evidence, all the above, growing from 40 terabytes to 8 petabytes in less than 5 years. So it's the largest data repository in the entire city and grew the fastest by over 10x than anything else they'd ever seen. And they had no plan when they first started. So cities are really looking for challenges to how to really democratize this shift from where they thought they were to where they are now.
While at the same time protecting personal privacy. So I live in the Bay Area, I live in San Francisco, and we just passed a law. I think we're the first city to pass a law that prohibits facial detection, facial recognition. And that doesn't exclude the ability for the city to employ technology like this to keep our environment safe and to automate a lot of capabilities. It just means that there's a Digital Citizens Rights Act, right? And I think we're at the precipice of a lot of these things being more pervasive around the world. Because the reality is the camera is ubiquitous. That's right. And 150 million cameras shipped last year. We're going to see the same amount, if not more, this year, and that's just going to continue. And what's amazing is that, and you know this, the types of algorithms that are going into these systems, either on these edge servers or actually onto the camera themselves, are becoming more and more sophisticated. I mean, we had one of our customers, I think that we worked on together, that was asking, hey, it's great that you can do license plate detection, and you can even tell me the make and model and color of a car, and pretty well accurately tell me the year as well. But can you actually have a camera that can do that for 100 cars that are going 70 miles an hour in a single frame in the rain or in a snowstorm? And of course...
Yeah, with engineers in the room, the answer was what? Absolutely. And then we had to go prove it, right? And really make sure it actually worked. And that's where AI and technology at scale is the big difference, right? So before it used to be capacity was the big thing our customers talked about. Now it's performance and capacity. Both things are very important to our customers.
So tell me, so we're in Vegas. There's cameras everywhere. Tell me what's going on outside of the casino in terms of what you're doing with the city, please.
I've never actually been outside a casino in Vegas. I think it's, I fall trap to prey to the design of no clocks and no windows, which thoroughly impresses my daughter. She has no idea why they would build a building with no windows and clocks, and we keep explaining it to her. She says, that doesn't make sense, only in Vegas. So Vegas is a unique city, has a lot of municipal challenges a lot of other cities do not have, right? So we have several thousand people here today. There's consumer electronics shows that have 150,000 people, and they might have 3 or 4 shows at the same time, having 500,000 people in the city that don't live here at any given time. These are real challenges that this city has that not a lot of other cities have on a day-to-day basis. So we're very fortunate to work with the CIO of City of Las Vegas, Michael Sherwood, to see how we can use AI, computer vision, and edge computing to solve some specific problems that they see here in Las Vegas they might not see everywhere else. And a couple of those problems that they really wanted to solve was cars driving the wrong direction on the streets here in Vegas. Which you could imagine happens, right? People not knowing their way around, a lot of tourists, a lot of people driving that probably shouldn't be driving. Maybe they bought the big yard ale thing outside the casino and walked around with it and thought, I could drive. I just drank one. It was just one. It happened to be 7 beers in one, but they drank it. It's just one. And so that's a big issue. So City of Las Vegas really is trying to solve that problem. Also, like any city, they want to keep their folks safe and their kids safe and their families feel safe when they go to parks. So they wanted to do 2 sides. One was predictive and helping prevent traffic violations and respond to those. And the other one was how can we tie in proactive safety and response together to improve the life of our citizens. So that was really the 2 big projects that we focused on first. We're going to do others, but that's where we started.
I asked my cabbie this morning, actually, if that 1% statistic sounded correct to him of cars going down the wrong way. And he said, oh yeah, ever since they legalized marijuana, we've seen a huge increase in people driving the wrong way.
Yeah, that wasn't in the RFP, but I imagine it had something to do with it.
So maybe can you talk a little bit about the technology and how Dell and Intel work together to kind of achieve those objectives of the city?
So as you mentioned, data and technology and decisions are moving more and more to the edge. And there's not a more edge in my world than a camera sitting on a pole in the middle of a street or a city or a park, right? That's about as edge as you get. But they also don't want to send all that video back. It doesn't make sense practically. They're not trying to use all the video. They're trying to make decisions real time with the data that the camera's seeing at the time. So deploying AI on those cameras with Intel openveno platforms and their analytics toolkits and their engineering team really allowed us to build algorithms on the camera at the edge to make decisions where it mattered most, when it mattered most, without having to send it all back to the core of the cloud.
Awesome. So you've deployed it, right? This is not a pilot or a prototype. It's actually in production. What's next for the city of Las Vegas?
Yeah, to your point, the 1% is kind of a national average, and your cabbie might agree that 1% seems a little bit light here in Las Vegas, considering that most of those incidences occur between 6 p.m. and 6 a.m. after people have been drinking. So it's about 6 p.m. to 6 a.m., 24 hours a day here in Vegas. So they see their fair share of those incidences all the time. But what's more important is not the 1%, it's the fact that 25% of those result in death. So it is a very, very high fatality rate. So it's one of those things that the city not only wants to stop because it creates havoc on the traffic, which is a big deal, but it creates havoc on people's lives and impacts people in a real meaningful way that they want to prevent. So we've deployed it, it's working, and we are driving safer parks, more autonomous decisions around traffic management and response to those incidences to hopefully prevent those from happening in the first place.
Awesome. Anything else you'd like to share?
Well, we're excited about the openveno platform, right? So more and more of my customers are saying, look, I don't want to do a separate card for GPU necessarily. I want to take advantage of all this power I have in the CPU, and I want to put as much at the edge and do as much at the edge as I can, as often as I can. So it really aligns quite well to what we're doing with Intel and the openveno platform. So we're very excited about the future. We're very excited about the joint opportunities we have, from smart stores to smart Coke machines to drone delivery to everything in between. So thank you for having me. I really appreciate the time.
Thank you. Cheers. So cameras aren't just limited to being on street poles. There's also mobile cameras, and a great example of how computer vision is being used in robotics is really just to understand their surroundings. It's spatial awareness for the purposes of autonomy, but also making them safer. And so there's been a lot of discussion around, do robots kill jobs? And you can probably find the answer to whatever your position is just by torturing the data, and you'll get what you're looking for. But a credible data source is actually the World Economic Forum, who believes just in the next couple of years that machines are actually going to create 58 million jobs. And if you think about the keynote from this morning, Amazon has added 200,000 robots to their facilities, while at the same time adding 300,000 jobs. So for them, the ratio is 1.5 jobs for every robot, which is not a bad ratio. And the types of tasks that robots are being used for are things where it's dangerous or it's a dull task, and being able to offload those to a robot is proving to be hugely important for productivity. And as a result, we're seeing a projected huge growth in robots, about 63% CAGR through the next 8 or so years from ABI Research. And one driver of the growth of robots is not just productivity, it's also for countries like Japan that have an aging workforce, where they need to bring automation and robotics into their economy if they're going to remain competitive. Or in cases like China, where with their Manufacturing 2025 initiative, which is part of their 13th five-year plan, it's a mandate from the government to, in fact, leapfrog other markets and bring as much technology into that process. But robots certainly can be highly autonomous, but mostly are being used to assist humans in warehouses and in dangerous environments. These are called cobots, and this is about 1/3 of the market for robots will be robots that are used to augment their human counterpart in a collaborative model. And these robots all require compute. They require a depth camera. They require deep learning algorithms running locally. They have functional safety requirements and have to have the ability for over-the-air updates. And one of the things that's been particularly difficult with robots has been programming them. Up until recently, requiring proprietary programming knowledge and skills. And so one of our customers has partnered with AWS, Aon, and they've developed a development kit for robots called Robomaker. This is the Aon Up-Squared kit. And what they've done is they've integrated hardware and software with CPU, inference capabilities, a depth camera, essentially to make it really easy for people to start experimenting with robotics. And this is what the dev kit looks like, which is all of these components integrated into a single package. So typically this would be something that an engineer or a developer would have to assemble and acquire individually. They've put it all together into a single package. And they've also open sourced 3D models so that you can actually print your own working prototype. So this is that same board in a 3D printed model so that you can actually start experimenting with this. And in both cases, it uses, again, the openveno toolkit for load balancing between the CPU, the integrated GPU, and the vision processing unit that's used for the cameras. And the real proof, I think, of a dev kit is not just is it good for experimentation and prototyping, but can a customer or a developer actually take it from prototype to production? And so what you see here on the slide is a company called Cogniteam, which is a company out of Israel that decided to do just that. And they took the Aon Robomaker board, and in a single day, they went from unboxing that component and that kit, getting the software set up, integrating it with their chassis that you see displayed here, and programming basic functionality. So, do you want to see a demo of that? Okay. I think here it comes. Okay, so what you're going to see on the chart as this robot moves onto the stage, on the far upper left you see basically the traditional optical sensor, the camera, which is doing object recognition. And to the right, you see the RealSense camera, which is doing 3D depth. It has multiple sensors like human eyes that can understand and avoid obstacles. And at the bottom is a GPS mapping data so that the robot understands where it is in any particular environment. And so, Paul, thank you for bringing this. Did you bring this all the way from Israel, or?
It was shipped here, but we do have the team here with us today.
So can you tell us a little bit about what we're looking at here?
Yeah, absolutely. I'm glad you asked, because a lot of people see this robot and they think it looks really cool. But this robot is actually going to be used for real applications. So one of the things that makes this robot unique or special, as you can see, is that it has the capability of driving either on roads, but it can also drive off roads. And because it can get to locations that other robots don't have access to, it opens up a unique set of applications for these robots. So one example of those applications that customers are interested in is actually using this robot to help with photovoltaics. So in a dry place, such as Las Vegas, oftentimes the solar cells will get covered by a thin layer of dust or dirt. So those photovoltaics need to be cleaned. Now, there are robots that can be placed on these solar panels, and they can be cleaned. And the Lynx can help by moving these cleaning robots from one solar panel to another solar panel. So that's one thing we're doing in industry to help improve the efficiency of photovoltaics. Another industry that we're hoping that the Lynx will help with is agriculture. So the Lynx comes with a 60-watt motor. It has a payload capacity of 50 kilograms. The Lynx can drive up to 25 miles per hour, and it can be used continuously anywhere from 3 to 5 hours. So this is great for agriculture because we can load the Lynx up with equipment that may need to go out to a field. After the Lynx is in the field, then any produce or whatever is collected on the farm can be loaded back into the Lynx, and it can autonomously navigate back to a warehouse or distribution facility.
That's amazing. I see, is there a beverage on the?
Yeah, it's a long talk, and we thought you might be thirsty.
I'm not sure if I want to drink something that's unlabeled. Let's see if it can tell me what it is.
Hold it a little close.
Yeah, oh, sorry.
Oh, Coca-Cola.
Okay, great.
Is that okay?
I'll save that for later. Thank you so much.
Okay, thanks for having me.
Thanks. All right. So what you've just seen is, I think, a great example of democratizing AI. Through a very simple kit, this company was able to very quickly build something and put it into production where they have real customer use cases in a business that they've built. Speaking of robots, you'll notice that they all use computer vision, which is a key application for AI at the edge. And there's a myth going around that we wanted to bust, which is this idea that the GPU is the hammer for all things AI. And certainly GPUs give great performance, but especially in edge inference, it turns out that the CPU delivers orders of magnitude better performance at a fraction of the price. And if you're comparing an Intel CPU, for example, versus the green team's T4 for inferencing, our customers are getting better performance per dollar, better performance per watt, and up to 3.7 times faster raw performance with a CPU, depending on which SKU they choose. And if that's not enough, you have the ability to add vision accelerator cards in the form of either a vision processing unit from Movidius or an FPGA like the Aria 10. And really, this is part of our overall strategy as a company, which is helping you harness the tidal wave of data that is upon us. And our vision is ambitious, and it's really to enable customers to move data faster, to store more of it, and process and analyze all of it with AI. So while other companies may tackle one piece of this puzzle, our intent is really to embed AI capabilities into our entire product portfolio, from device to cloud, as well as supporting it all with software and tool sets. One of those tool sets is something called openveno, which you've heard mentioned a few times today. It's an open source tool. That's what the open portion of the name is, and Veno is visual inference and neural network optimization. And essentially what we wanted to do is help the developer defragment the experience of building, training, and deploying algorithms with a simple tool. And we just had its first birthday. It's been growing incredibly fast over the last year, and in fact winning a lot of industry awards. Last week, for example, at the Embedded Vision Summit, which is kind of like the Academy Awards for computer vision, openveno won Developer Tool of the Year. And the way it works is it basically abstracts the hardware from the application development and the data science so that you don't have to understand hardware architecture to be able to train and optimize your algorithms onto Intel hardware. It does that for you, and it allows you to write that network in any framework tool of choice. It's completely tool agnostic, and deploy it on any compute platform, whether it be a CPU, a GPU, an FPGA, a VPU, and make it really easy when combined with our AI in production program, which you saw an example of earlier, to essentially leverage our ecosystem to take that innovation of yours and drive it all the way through to commercial deployment. And openveno gives you an incredible performance boost. So if you look back a year ago and say that Intel first generation Xeon Scalable is your baseline, with our first version of openveno, we were able to double the inference performance on that platform just through software alone. And then recently, about 6 weeks ago, we launched the second generation of the Intel Xeon Scalable, and a combination of embedding a vector neural network instruction set into silicon, which we call DL Boost. That combined with openveno is now giving over 28 times inference performance over the baseline, which was just a year ago. So it's just extraordinary performance improvements, and it's an example of how we're incorporating AI into everything that we do. So what's next? Next month we'll be launching a whole new set of capabilities as part of the tool set. Right now, the key drivers of value are the model optimizer, which takes very complex neural networks and has the ability to shrink them down to perform at the edge in lower compute environments without any loss in accuracy, as well as an inference engine which allows for high throughput on those platforms. What we're adding are a couple of capabilities. One is an open model zoo. So we already have some pre-trained models in the toolkit, and what we're going to do is add additional trained models for various use cases that are performant. They're pre-optimized expert models that you can then take and customize for whatever needs that you have, and we make those available to you as part of the toolkit. The second thing is we're going to be launching a computer vision annotation tool, which, unlike AWS Ground Truth, is a general purpose tool which is optimized for computer vision. And so what this will allow you to do is import an openveno model, and it will use inference to automatically annotate a video feed. We use it ourselves. We're finding that we get anywhere from 2 to 10 times the 2 to 10x reduction in our annotation costs as a result of using this tool, because so much of it has been made automated. The other thing we're doing is launching a profiling tool which will connect to a dev cloud. So what this allows you to do is take your neural network and be able to understand how it's going to perform on a variety of different hardware platforms without having to make a purchase decision. So you can actually run this on hardware platforms that are running in our dev cloud, and it will deliver back to you how those are performing. So you can find the sweet spot of any DL model, whether it be latency or throughput, power, hardware cost, even if you don't yet own that hardware. And all of this technology works with our ecosystem. So we have this AI in production program, which is really designed to accelerate your solution development. We give you access to technology, to training, to ISVs, systems integrators, distribution partners, everything you need to get you a solution to market. So we're coming into the final stretch, and I want to talk about what is, to me, one of my most passionate areas of AI, which is the application of AI to healthcare. This is really, I believe, the cutting edge of AI. I think you saw some really amazing stuff this morning. And what we wanted to do is make it personal. And this is an industry with uniquely large data sets and data variety. And in fact, I read recently that 30% of the data being created now is health-related data. It's just a vastly growing collection of highly diverse things, everything from a digital medical record to an MR, PET scan, CAT scan, MRI, X-ray, sonogram, mammogram, just huge volumes of data. And this is an industry that needs this transformation desperately. We've all seen the stats. The population is growing, and at the same time, it's aging and requiring more healthcare. But as healthcare grows as a percentage of GDP, the estimates are that it's going to become increasingly difficult for us to analyze all this data that's being created. In fact, in the US alone, it's estimated that we will need to add somewhere between 25 and 50% more people to analyze this growing data set, which obviously is an invitation to invite technology to solve the problem because our healthcare costs are already too high. And this is something that we have to act upon, or else we potentially leave hundreds of millions of people around the world without healthcare. And there's a transformation that's going on here in this industry. It's historically been a centralized mainframe model of care delivery, which is one of the contributing factors of skyrocketing costs, but also simultaneously decreases in outcomes. And so as an industry, and you're going to hear from a moment of an industry leader, what's happening here is that we have an opportunity to personalize the healthcare experience by leveraging your data. And so either that can be your data as a standalone data set or as a value exchange contributing your personal data to a population health record where you can get insights from other people that may share similar demographics as you do. The second is that healthcare is becoming distributed, so no longer will the hospital be the sole exclusive provider of care, but it will be distributed out into other facilities and even the home to where the care is best delivered. And lastly, it will be coordinated across specialists and across providers with that data record being something that's consistent and unique to you. But digitization is not enough. Right now, as you can see, just a crazy amount of data just in the next year, growing at almost 50%. I don't know what's bigger than an exabyte, a helabyte. It's a lot of data. And what we've learned in any industry is that a giant data lake doesn't lead to better outcomes. We need to apply better techniques to analyzing this. And one of the companies that I think is leading the way, a great partner of ours, is GE Healthcare. And so I'd like to invite Keith Biglow to join me on stage. Keith is the SVP and GM of AI and Analytics at GE Healthcare.
Indeed.
Keith, thank you for coming.
Thank you.
Help us understand, what is so complicated about this problem? Why is healthcare data such a challenge?
Healthcare data is a challenge, one, because all of the systems inside a hospital are isolated, so your data is not pooled together easily. And secondly, it's your data. And so actually getting that data, respecting your privacy, so that we can create new algorithms is a very complex task. And it's governed here in the US by HIPAA, in Europe by GDPR, and in many countries, we can't access data because of sovereignty laws, for example.
But there's also a variety of different types of data, like you're showing on the chart, right? It's really almost an infinite space.
Yeah, it's interesting. Healthcare data, if you think about each one of you in the crowd right now, the challenge is we need to be able to detect a condition in your body using any one of the physics that we create, MR, CT, X-ray, et cetera. And then we need to do it by anatomy. So you multiply physics times the anatomy times all the medical conditions that we can detect, and it is a huge vector space. So for just a chest X-ray, for example, 800 plus conditions. And this is where our real challenge is in healthcare is how do we deal with those costs and all of that huge data volume over this massive landscape that we have to address with algorithms.
And so you're taking an interesting approach, which is building a platform, the Edison Platform. I was hoping you might be able to tell us about the platform itself that you're building with Intel and AWS, as well as the role of the developer in solving some of these problems.
Awesome. So because we have thousands of algorithms we need to create, we need you, an ecosystem to help us build these. And so how we're working today is partnering with a hospital to join the report from your scan and then de-identify it. And then we bring it up into the cloud where we store it, we index it, we secure it. And then we annotate it the way you were describing with the CBAT tool that's coming out next. We use humans to annotate this, to actually mark exactly where the lung nodule is, exactly where the collapsed lung is. And that helps us to train the algorithm with perfect ground truth. And then we actually can deploy it into the medical device. We can deploy it at the edge if we want to manage a fleet, or we can deploy it to the cloud. So where we don't have radiologists, for example, they can upload the scan, and then we can inference in the cloud and drop it right back down to their systems.
That must be hugely important for accessing remote areas that are lower income countries where you're trying to basically have the same level of care without the cost of the infrastructure or the expertise.
Yeah. Indeed, we serve about 160 countries. And it is incredibly challenging, especially for emerging markets, Africa, Asia, et cetera, for us to be able to deliver this capability at a price point that the market can really tolerate as they try to serve ever-growing populations, as you showed.
Can we maybe look at a couple of examples
Sure.
of what's happening
Perfect.
right now? I think you gave us a couple of images to show.
So this first one is for MR, and it's MR Neuro, so your brain. So we want to scan your brain, Miriam, this woman right here up front. And if we want to scan her brain, there are about 100 variables on an MR device that the operator, the technician, can tune to get a perfect scan of her brain. But let's say that we actually want to compare it to a scan 3 months from now because we want to see if she's getting better. Well, what if my operators are different? And what if they set different variables? Now we have variance, and we don't know if Miriam's getting better or not because we have no idea if the scan is showing us the same. So with this algorithm, what we did was we used the localizer scan, which is nearly instantaneous, and we map an atlas of Miriam's brain. And then we tune the scan plane to be perfect just for her, or just for Dan, or just for any one of you in this room. And the awesome part of this is when you come back 3 months later, this MR device will take the exact same scan. No matter if your head is tilted, rotated, anything, we correct. And this is running on Xeon processors that were already in the device. So we didn't have to augment the cost. We can just deliver this to our customers directly.
So just by updating the algorithms that those devices are already running,
correct,
you were able to achieve this result.
Yeah, so this is 510K cleared. This is already something that we're really proud of.
Amazing. This must have a huge impact on diagnostics.
Well, it's going to. As you think about all of the scans that are done and the variance that's happening, what we're really excited about is eliminating that variance so that the quality of care goes up and we don't have to re-image a patient in order to know whether or not indeed their tumor is getting smaller, for example.
And you can also deliver the results to the patient in real time at that same visit, right? They don't have to come back or consult with someone over the phone.
Correct. Because it's a perfect scan, we can act on it much, much faster than having to ask that patient to come back 2 weeks from now and re-image them because we didn't get it just right.
Can you maybe give us another example?
Absolutely. So let's pick someone who doesn't deserve to have this happen to them. This beautiful woman in the purple shirt here, let's pretend that after this session, she's in a car wreck.
Oh, no.
And she goes to a local hospital, and here in Las Vegas, they're awesome, so you're going to be fine. And they will perform surgery, sew her back up, and at the end of that surgery, they'll perform an X-ray. And the reason for that X-ray is to determine, does she have any remaining critical conditions? So on this algorithm, and a portable X-ray that's inside the emergency room, we have injected an algorithm into the device itself. And you notice there's a red light on this particular one. So it's flagging we found a critical condition in your chest X-ray. The algorithm did that. And what it found was a collapsed lung, or a pneumothorax. So before you're ever wheeled out of the operating room, the care team is alerted immediately, notified that you have a collapsed lung, so that they can reinflate it so that you can actually safely recover. Imagine if this algorithm doesn't exist, and it's missed by the care team as they're rolling her out of the room. She may crash in the middle of the night. But because of this algorithm, it's going to be detected, they're going to be flagged, and they're going to take care of you right away. So this is another great use of partnering with Intel and the openveno team to inject into, in this case, an i5 chip, the ability to inference in real time and be able to detect these medical conditions right away. I'm sorry I did that to you.
So what I like about that is, there's always this assumption that you need massive computing resources in order to perform, AI tasks, and here you're using an i5 to deliver pretty high medical benefit, which is amazing. We've been talking a lot, both earlier in the keynotes as well as in this session, around this idea of democratization. So you talked about how you're trying to access all of these 160 countries. Can you maybe talk about that a little bit in the context of X-ray as well as some of the real-time components?
So the real trick for healthcare is to inject AI into the device at as low a cost as possible and have the performance be there so that you get the eyeballs of the care team before the patient leaves the room. So in this case, we actually came to Intel because we started to chain models together. So what you see on this slide is, first we wanted to know, is this a chest X-ray? Because we don't want to perform the inference if it's a leg or a hip or something else, right? You're going to get a false positive or a false negative, and that doesn't solve any problem. So our first model just says, yep, it's a chest. The second model says, is it a good chest X-ray? Do we have the contrast dose that we need so that we can perform a proper inference? Yes. And then third, we go ahead and inference to see whether or not your lungs are okay. In this particular model, we were struggling because we have to deliver this particular X-ray globally. And to your point, price pressure is huge. And so we actually approached the openveno team to say, hey, help us to accelerate this. And what we did in working with that team...
You gave us a pretty specific challenge,
to
be clear.
Was if we can't get eyeballs seeing that red light in under a second, the care team will miss it. And if they miss it, this patient may not make it. So this was an awesome example of great partnership with Intel and with openveno to be able to get this under a second, taking care of patients like everyone in this room for any surgery you might have.
It was a great partnership, and we really appreciate the collaboration, the ability to work together to solve these really hard problems, which have never been tackled before, and that makes it even more rewarding when the outcome of that collaboration is, healthier people, saved lives, et cetera. So Keith, thank you so much for coming.
Thank you.
And for the continued collaboration. So I think everyone, at the event, us especially, are profoundly excited by what the next 10 years can bring. And not only for what we are experiencing in medicine, but across every industry. And it's absolutely going to transform our lives and make the world a better place. And what we believe will accelerate that is really democratizing access to technology and making it super easy to adopt, as well as speed the time to benefit realization. But I don't think any one company can do it alone. That's one of the great things about REMARS and bringing everyone together is the ability to form coalitions and the ability to share innovation and learnings across industry and to collaborate. These are the things that will accelerate all the wonderful benefits that we all envision. And I want to thank you for your time today, and I hope you have a wonderful rest of the conference.